Hi everyone, in today's video we'll be building a full stack AI project covering all the major AI engineering skills like RAG, LLMs, context, evals, observability and much more. And if you follow along the whole tutorial, you will be able to add this project in your resume, share it online and get more attention of hiring managers and recruiters. By the end of this video, you will be aware of how RAG pipelines are built and you will be building your own, how MCP servers work or how you can integrate APIs in your LLM project. We will be using AI coding agent Codex for this project. You can use any other like Anti-Gravity, GitHub Copilot, Grok or Claude Code as well based on your preference. Now without any further ado, we'll get started with this tutorial. I request everyone to follow along the tutorial so that you don't miss any concept. Coding is almost solved with coding agents. The main focus should be learning about these concepts and how these things work. And if you have any doubts, just put them in the comments, and I would highly request everyone to please like and subscribe to the channel for more such amazing content. And now let's jump onto the PC. Now before we put our first prompt in Codex, let me explain you what problem we are trying to solve or the project we are trying to build. We are building a website RAG system. Essentially you will be providing a website URL to your project and it will create a RAG pipeline which will be able to answer any questions that you ask it later on. Now why it's a difficult problem to solve? Every HTML website or any website on the internet includes a lot of components and it's not that structured. What data to be used for that RAG pipeline? You cannot include everything which is available on the website, but the right data, structured data that needs to be inputted in your database, converted into chunks, then included in the vector database, because that's how the RAG stores everything into vector DB in form of embeddings. And this is not another application where you upload a PDF and simply add a chat interface just like a chatbot answering from a FAQ data. The user will provide a public website URL, any website on the internet, to our tool, and they'll be able to ask questions through it. Now we will be using Context.dev tool which will fetch the web page and convert its content into clean markdown. Then we will divide the whole markdown into small chunks and create embeddings for those chunks and store them inside a vector database. And the final answer will also have citations or groundedness that this data is taken from the particular web page and these are the sources for the same. And finally we will run the evals also to measure whether the retrieval or the generation answer was actually correct or not. This whole system has covered API integration, vector databases, RAG, LLM integration, tool calling, tool usage of AI tools, markdown, evals and everything. It's a full AI pipeline and you will be learning all these topics. I will be explaining everything in detail, and now we'll go ahead and write our first prompt. So this is the Codex window, as you can see. Okay, so this is the Codex window where I have put in the first prompt already. I'll expand it. It covers everything we talked about, what evals you need to add, how the knowledge base would look like, how the front end would look like. I have made it through reverse prompting. So I have given the idea to LLM. It could be ChatGPT, it could be Gemini, it could be Copilot. You give what you want to build and ask it to write a prompt for it. So it has written a prompt for me. I have divided the whole process into multiple prompts. This is the first prompt and this process is called reverse prompting. You ask an LLM, you give a prompt to write a prompt for yourself and it has started building. Now if I'll talk about the main and most important step, which is ingesting the website, how we are fetching the website URL, we are scraping, or what we are doing, we are using Context.dev to get that data, HTML data, and then creating a clean markdown for our context to be stored in our RAG DB or vector DB. See, the important caveat is a normal web page does not contain useful text. It also contains HTML components, it contains navigation bars, scripts, cookies, banners, repeated footers, images, and many other things, right? And we don't want to input everything to all that unstructured data to our language model. We could create maybe our own scraper also. You can create your own scraper, but then you have to define all the rules to what HTML components you want in the vector DB and what you want to ignore. You have to specify everything, and it will change with every other website that you will be using, because every other website has different tags and different components. So instead of writing custom scrapers for each and every website, we will be using Context.dev. Let me quickly open Context.dev for you. Sign up is very easy. You can just sign up with your Google account or create a new email. You can extract every bit from a website URL as mentioned here. You can convert it into a markdown image, or extract the logos, colors, fonts. You can extract and download the images from any web page or any sitemap or style guide or even screenshot. And there are other things also like fonts, HTML, ID transactions, so on and so forth. This particular startup is being backed by Y Combinator also. Let's give a quick tutorial how, let's take any website, right? Maybe we can take my GitHub. Let's take my GitHub URL or maybe my Twitter, or let's take my GitHub URL only and put it here. Okay. And it will start connecting, fetching page content, parsing HTML, converting to markdown, and it has shared everything in a manner which can be shared to any LLM, so that it will have the right context also. And we will be using Context.dev using its API key I have already generated, which can be easily generated through your dashboard. You can go to your dashboard. I will disable my key so you don't have to. I've already used it a bit. You can go to API keys and there will be default API key which you can consume, and you'll get free 250 credits runs which you can use with a free account. It's a free plan which I am also using. You can use the same. Cool. Now let's jump on to the third most important thing. Let's see how far Codex has gone. So it is still building. Let it build. We will go to the third part of this website, which is chunk and embed. So there is a lot of confusion around what are these chunks. Chunks can be divided into multiple types of chunks. It could be section level, it could be paragraph level, it could be word level, or it could be semantic level also. So we try to split around headings, paragraph, boundaries, or so that each of these chunks contain one meaningful piece of information. So generally word chunks are not being used because obviously it doesn't contain any semantics or context. Then every chunk is then converted into an embedding. Now embedding is simply numerical representation of the meaning of the text. So whatever chunks we have converted, each will carry a meaning, and that meaning is converted into an embedding, a numerical representation. Okay, and then that numerical representation is stored in a vector DB. How a vector is represented in a vector database? By numbers, but like decimal numbers, negative, positive, depending upon how so this vector is found when you pass the data through an embedding model, and we store these embeddings along with the original chunk text source URL inside a ChromaD, which is a vector database. Then later when a user will ask a question, it will also be converted into an embedding. So the question will also be chunked and then converted into an embedding. And then we compare the question vector with the stored chunk vector, hierarchical navigable small world. So this is one of the algorithms which is very commonly used, and then it will be used to find the sections that are semantically closest to the question, and this particular process is called retrieval. I hope you understand what retrieval stands for in RAG pipeline. And I guess the first prompt is completed. So the first prompt is available. If I'll click on so the backend is working. Let me click the front end also. And the front end also looks pretty nice. And this is the website URL where we'll be putting the knowledge base. This is the ask, and this is the eval. Now in our project, we are using OpenAI APIs, which will help us in the embedding, chunking, and all those stuff, and also retrieve the answers from our RAG system. Yeah, we are just integrating Context.dev in this particular prompt, and let's get started. I'll provide the API key from Context.dev because I am using the default API key only, and I'll provide it, and I'll delete it later on. And it will automatically put that API key in .env file. You generally should not provide your API key like this. Since it's a test project, I'm doing it like this. You should store it somewhere and give the path to that file. So now the most important part, converting the markdown into RAG knowledge base, which is searchable. Now we have created specific like backend and frontend folder. The structure is very simple. We are keeping minimal files, and the function that needs to be added are chunking the markdown and creating the knowledge base. While the retrievable chunks would look like there'll be a question, there'll be top k, which is by default 4. Then chunking requirements is simple. We need to split the markdown into understandable sections, prefer markdown headings and paragraph boundaries, approximately 800 characters per chunk. So this is more like we are using section based chunking or paragraph based chunking. Ignore empty chunks and give every chunk a ID, chunk number and text. Then the source URL. Embedding requirements, we'll be using OpenAI Embeddings API. We'll be using OpenAI model as an embedding model, and the one which we checked on the internet also for embedding and converting into vectors. Now vector store requirements, we use Chroma in local persistent mode and use one collection named as website knowledge. What else? Important details. Return each chunk with these details. Update. So this is the URL routing for creating the knowledge base. Update the knowledge base tab to show. So the knowledge base UI will show ingestion completed, number of characters, number of chunks created whenever you put in a URL. And that is it. You have to provide your OpenAI key also. I have already provided, which will get expired after this video. So whenever a user asks a question, we do not really go to our language model directly with that question. First, we create an embedding for that question and search our vector database. Now, imagine you have created the embeddings initially and stored it into the searchable vector DB. Similarly, these chunks are also passed to the same embedding model, and then vectors are created and the similar vectors are being searched. Now, since we have set the default to 4, the system will retrieve 4 chunks that are most relevant to that particular question. So 4 chunks will be retrieved. This is just a pictorial representation. We will label those chunks as S1, S2, S3 and S4 and send this selected context to the model. Once that context is being shared to the model receives strict instructions, answer only through supplied context, nothing fabricated. There'll be nothing that the model will answer based on its own knowledge. It will be answering based on the context being provided. And the response will also be grounded. It will share the relevant source labels and clearly say that if the information is not available, it will clearly mention that as well. And the good part is every user can also check what chunks are being generated in the retrieve context section. So they'll see those 4 relevant contexts being generated, the 4 answers being generated from our RAG pipeline. Validation is very much important. I am not covering that in this particular video because I believe that is expected and you should be doing after every prompt that you write, that things are working properly. The functions that needs to be added in this prompt are answer question, how it should work, it should call retrieve chunks with the question and top 4k, S1, S2, S3, S4, label the retrieve chunk like this, send only those chunks to the LLM, responses API, instruct the model to answer only from the supplied context, and then require citations such as S1 after the factual statements. And what else? Environment variables, we have already added OpenAI key, and then this is the request response structure. Update the ask tab. Then this is related to the front end changes. Now understand, I am able to write these kind of prompts because I am using reverse prompting. LLM is writing it in a structured manner. So question answering done. Post this, we will be doing the evals. Like we'll be building a very small evaluation system which will give us like confidence score that things which we have built is working properly. Okay, let me open that. Okay, so this was our question answering system. Now we'll talk about our eval system. Evaluate answer. You won't imagine there are companies who are working on this problem statement itself, just evaluations. Our RAG system will be able to generate answers, but it does not really make it reliable. that those answers are correct, or it will generate right answers in the future also. So evaluations are very much important, just like your exams. So our application will run the same retrieval and answer generation pipeline, and then it measures it into 4 different areas. First of all, it's the retrieval relevance chunks, like whether the system has found the correct pieces of the context or not. That is the first stage. Second is groundedness, which checks whether the generated answer actually is supported by the context we have given or the retrieved chunks that we have given. Third is correctedness, whether the generated answer actually matches with the expected answer or not. And then fourth is citations. It checks every citation in the response maps to a label that actually was provided. So these 4 matrices are combined in for the overall score, and it will give us the pass or fail, or it will measure the quality of our responses. So we just saw how the evaluation will be done, right? Now we'll be putting that into a prompt I have already put in actually. So this was a prompt I put in for evaluation. Now add evaluations to measure the RAG system. We gave 2 parameters, question and the expected answer. And how does it happen? It runs a normal answer question pipeline, collect the generated answer, collect the retrieved chunks, and then check citation validity deterministically. Then use OpenAI evaluator to generate the score: retrieval relevance, groundedness, answer correctness. So we have used OpenAI for embedding, OpenAI for evaluation, and we also used OpenAI for what else? For generating the response also. And these are the matrix, the meaning of these matrix, and we'll be using a 70% criteria for a pass or a fail. Okay. Yeah, and then the information about the backend and the front end. So the last prompt is just to refactor the whole application. The whole application is complete. Do not add any new features, and the important custom logic should remain concentrated in backend main, backend RAG, front end, these 2 files. So we have kept it very small, concised, and then the requirements: remove duplicated code, basically refactoring the whole code. And if I'll just go through the system design of our project, which looks like this. So the whole system design that we have built has a React UI, which has a knowledge base, which has a ask and evals tab. Ask tab is where you ask the question, knowledge base is where you put the website URL. It creates the knowledge base, create embeddings, and then when you ask the question, chunks are being retrieved, given to LLM to generate a response, and those responses are being evaluated by OpenAI itself. Our backend is orchestrated with Fast API framework written in Python, which interacts with Context.dev for fetching the markdowns, converting the markdowns for the data being fetched from these websites in our knowledge base. Then ChromaDB for embedding vector databases, and then OpenAI for all the other stuff. See, our system is very small, but it is complete. It covers all the important topics that an AI engineer needs to have on their portfolio. So this is what I wanted to teach in this particular video. I have tried to explain each and every bit. If you still are unsure, not able to understand, just let me know in the comments. And now we'll basically jump on to the testing of this particular project. Let's take the Wikipedia of Thomas Alva Edison, and let's give that as a URL knowledge base for our website, for our RAG pipeline. We will start the ingestion, input it. Okay, wow. So there are like around 200,000 characters and 330 searchable sections are being created. This was the URL. Now we can ask questions. So for example, when did Thomas Alva Edison was born? Okay, now this will not use the internet, but it will use our chunks. Now how will I verify it has used the chunks? Because so it has given the right answer. It has used the first chunk. Which was that chunk? It has given the link to that as well, and retrieved context also it has given. This was the retrieved context, And chunk 1, if I'll click on it, it has redirected me to that URL, like what exactly the citations basically, right? Now let's ask another question. How many or when did Thomas, okay, I'm just writing Thomas, I'm not writing Thomas Alva Edison, so that even if we just want to verify that it is not using the internet, it will be able to do it. When did Thomas did his first invention, and what was that? S4 chunk, so chunk S4 has this information. His first patent was electric vote recorder, and it was granted on June 1. The chunk is, it is redirecting to the same Wikipedia page. So this is a complete full stack project, and we have evals also. We can check evals also. Okay, we'll run the evals now. So it will see if what the confidence score, if these questions were given to the model, to the RAG pipeline, are the answers being generated near around what's mentioned here. Let's see what's the result of the evaluations. I hope you have enjoyed this video, learned something out of it, and if you want more such tutorials, just comment down below. Using Context.dev is very easy. Just use the link mentioned in the description below. You will get the free credits to try it out. Amazing tool to be included in your LLM projects, and make sure to add this project on your GitHub, share it online, tag me so that I can also share my feedback. I'll see you in the next one. Till then, bye bye, take care.